If you travel across India, the sheer physical whiplash is striking. You can stand in a dense, humid rainforest, and within a relatively short distance, find yourself staring across an arid, sun-baked desert. Look in one direction, and you will find sweeping, crescent-shaped sand dunes. Look elsewhere, and you will see small, vibrant coral atolls floating in the ocean. And stretching across the entire northern border is the highest, most rugged wall of mountains on Earth. Beneath the surface, there is a massive geological tension. The southern part of the country is a piece of one of the oldest, most stable land blocks on the planet. But millions of years ago, this ancient landmass drifted north and slammed into the Eurasian plate. That collision thrust the land upward, creating a highly unstable and violent geological zone in the north. The result is a highly interconnected geographic engine. Every extreme landscape you see here provides a precise, vital resource required to sustain the rest of the subcontinent. The oldest component of this engine is the Peninsular Plateau in the south. When that original landmass broke apart and drifted, it left behind a vast raised tableland made of old crystalline, igneous, and metamorphic rocks. Because of its volcanic and tectonic origins, this stable rock acts as the subcontinent's industrial storehouse. When you dig into the terrain, you find massive reserves of minerals and coal, providing the raw materials necessary to drive modern industry. Just to the northwest of this dense, rocky expanse, the environment strips away into the Indian desert, a region defined by low rainfall, arid climate, and undulating plains covered in sand dunes. Moving to the extreme north, we find the exact opposite of the ancient plateau, the Himalayas. These are geologically young fold mountains that form a continuous, towering arc along the border. This topographical map shows the longitudinal extent of the Himalayas. It consists of 3 parallel ranges, the inner Himadri, the rugged Himachal, and the outermost Shiwaliks. Their sheer altitude makes them perennially snowbound water towers. Glaciers melt and give birth to the subcontinent's critical river systems, specifically the Indus, the Ganga, and the Brahmaputra, which flow outward from these ranges. You have an ancient industrial foundation in the south and an endless supply of fresh water frozen in the north. But raw minerals and distant glaciers cannot sustain a massive human population on their own. You need a mechanism to bring them together. Following those fast-flowing rivers down from the mountain valleys, we reach the northern plains, a vast, flat expanse of land stretching across the subcontinent. For millions of years, water eroded steep mountain slopes. Reaching the gentle basin, the river slows and deposits its payload, pebbles in a narrow foothill belt called the Babar, and fine nutrient-rich silt, known as Kadar, across the wider floodplains. This continuous deposition of alluvial soil, combined with a reliable water supply, creates ideal conditions for intensive agriculture. It forms the granary of the country, generating the biological calorie base required to feed over 1 billion people. Stepping out toward the fringes, the central plateau is bordered by raised ridges known as the Eastern and Western Ghats. From these heights, the land drops abruptly into narrow coastal plains, running along both the Arabian Sea and the Bay of Bengal. Further out, the engine extends into the ocean. On the western side, the Lakshadweep Islands are formed entirely of small coral atolls. Eastward, the Andaman and Nicobar chain sits on a more volatile foundation. As seen with this active volcano, these islands are elevated submarine peaks. These coastal stretches and scattered islands provide dense biological zones and rich fishing grounds. Crucially, they offer the deep water ports that take the output from the interior and connect it outward to the global economy. This India relief map reveals how these physical features work in tandem. Water falls from northern peaks into fertile river valleys, sustaining the agricultural population. They utilize massive mineral deposits from the central highlands, moving resources out through narrow coastlines. None of these environments exist in a vacuum. Their structural complementarity creates a rich concentration of natural resources. The ability to sustain early human civilizations, support a massive modern population, and fuel future economic growth is hardwired into the geographic machinery of the land itself.